So if I have in a square root a fraction, I am allowed to split up the fraction. So for example, in this case, I am allowed to write this one as the square root of 49 over the square root of 4. Do you see that? You just split it up. And then I do the numerator separately and I do the denominator separately. So what will be the square root of 49? What will be the square root of 4? 2. And that will be it. Okay? Now, take a look at the 50. Sometimes we get lucky and they're perfect squares. Sometimes they're not. So take a look at this one. First, I'm going to split it up. Root 50, root 81. Okay, now, is 50 a perfect square? No. So I'm going to do prime factorization. It's 2 times 25, 5 times 5. So look at this one. In the numerator, this pair of 5's come out, and the root 2 will stay. What about the denominator? What's root 81? 9. Now, look at the numbers that are outside of square roots. I have a 5, I have a 9. You now have to ask yourself, are the 5 and the 9 able to be reduced with each other? No. So you'll leave it. But if they were, like if it was a 3 and a 9, then you would have to reduce. Okay. But only numbers that are outside pair up with outside. Remember, the 2 is inside the escape room. It can't associate with the people outside. Okay. Now, all radicals, this is what I was saying before, all radicals must be eliminated from the denominator. Okay? This process is called rationalizing the denominator. Okay? How do you rationalize the denominator? You multiply the numerator and the denominator by the same radical. Okay? So let's see. Look at this one. The 2 can't simplify any further. Root 3 is root 3. It can't simplify any further. So you would think, okay, this is done. This is simplified. No, I am not allowed to have a root in the denominator. So now I need to rationalize the denominator. To do that, what I need to do is I need to multiply by the identical root, root 3. But if I do it to the bottom, I have to do it to the top. So now, take a look at what happens. Here, I just have 2 root 3. Okay? Here, I have the square root of 3 times 3, which is the square root of 9, which is what? 3. And that's how I leave it. And so now, for that denominator, we should never be doing that much work. You should just know root 2 times root 2 is 2. Root 7 times root 7 is 7. Root, let's see, root 8 times root 8 is what? 8. Okay? Root pencil times root pencil is what? Just pencil. The roots cancel out. Okay? So we need to know that. All right. So let's take a look at this next one. First, I split it up. Root 10 over root 3. Now, can the root 10 simplify anymore? Yes. How? 5 and 2, but then it can't come out of a radical, so it just stays root 10. Okay? There are no pairs. So you would think we're done, but are we? No. What's the problem? There is a root in the denominator, so I'm going to multiply by root 3. Multiply by root 3. Now, the denominator should be super easy. What's in the denominator when we're done? 3. Root 3 times root 3 is 3. Here, when I have a root times a root, I get a root and I multiply the inside. So this will be 30. Yes. But yes, but it's root 9. Root 9, which is 3. Okay? This one would have been root 4, so 2. Root 49, so 7. Root 64, so 8. Of course it makes sense. It's math. Right? Yes.
So wouldn't this always be the same number?
Yes.
Just
always this. That's what we said. Root pencil times root pencil, just pencil. Yes, it makes sense. It's math.
Yeah.
Okay. Yeah.
So why did we do? Wouldn't it be? Oh.
Okay. Root 14. What's 14 made of? 7 and 2. Does anything come out? No. Nothing comes out. So that just stays as root 14 over 5. Do I need to do anything else here? No. So this is it. This is simplified. Okay? Here. Okay.
So you just can't have a square root in the, you can't have a root in the denominator, basically?
Correct. Okay. Now, here we go. This one, okay, lots of different ways to do this one. Look at the 6 and the 12, right? So look at what we're going to do. Do you see how when they are together in a root, I separate them?
Yeah.
But also when they're separated, I can combine them. So let's see if we can combine this. Let's combine this 6 over 12. Okay? It's always like combine, separate, right? You can always do that. So what happens here? This is, if you divide by 6, I get a 1, I get a 2. So 1 over 2. Now, again, when they're separate, I combine. When they're combined, I separate. Let me separate this. Root 1 over root 2. What's root 1?
1.
1 over root 2. Am I done? No. Multiply by root 2 and root 2. So now, in the numerator, I get 1 times root 2, which is root 2, over what? 2. Okay? So, when they're separate, you can combine. When they're combined, you can separate. And then, okay, there are more than one. So this one, it was the square root of 10 over 3. I separated them. This one was separate. I first combined them to simplify. Okay, let's do this one. So let's multiply now radical expressions. Now we're really like at like, you know, like it's like the boss level, right? So let's do this one. Okay. Remember how we have the escape room situation. So here's the thing. If you're inside the escape room, you can't hang out with people outside. You can't associate with people outside. You can only associate with the people inside. And if you're outside, you can only associate with other people on the outside. This we need to keep in mind. So take a look at this one. When I have this and this that are outside, I can multiply them. But look, this and this are inside. Those can get multiplied together. Okay? So outside people with the outside people and so on. So take a look at this one here. Okay? Here I have 3 times 4. Those are both outside. 12. Now, root 2 times root 2, how much is that? 2. So together, that's 24. Okay?
Wait, is it not 12 square root of 2?
No, it was the square root of 4. Okay, look at this one. Outside, I have negative 2 times 5, how much is that? Negative 10. Inside, I have root 6 times root 3. That's root 18. So now the next step is, can I simplify the 18? And you know what? Yes, I can. So this is negative 10 times, let's see what 18 is. 2 times 9, 3 times 3. So what comes out? What comes out? A 3 comes out. What stays in? The 2. So I have negative 30 root 2. So from the negative 10 root 18 and on, this is what we did yesterday. All right? Yeah. Okay. Here. Okay, what's on the outside here? I have the 6 times the 10, that gives me 60. Then I have root 10 times root 5. These are both roots. They multiply inside a root, and I get root 50. So let's see what 50 is. 2 and 25, 5 and 5. So take a look. I have 60 times. What happens with this? What comes out? 5 comes out. What stays in? The 2. So this is 300 root 2. Okay? Okay. Now look. Let's do a little bit of practice up here. If I have root 5 times root 7, how much is that? Root 35. If I have root 3 times root 2, how much is that? Just 6? Root 6. If I have root 2 times root 5, how much is that? If I have root 2 times root 2, how much is that? Okay, good. That's where I was going. Do you see that? Yes? It's important to know when you keep the root, when you don't keep the root. Okay, good. So let's go here. 7 root 12. This is just like what we did yesterday. So take a look. The 12, I can simplify. 2 times 6, 2 times 3. So here I have 7. What comes out of this blue thing? Whatever has a pair comes out. So the 2's come out. 2's come out. The 3 stays in. So that's 14 root 3. Yep.
Then you have to do the little, like line on the apple.
Huh?
Like you have to do the little tail.
No, I mean, it doesn't matter. Okay. So take a look at this one. The 2 is outside, and then I have root over root. Root 3 is simplified. Root 6 is simplified. It seems like I can't do anything, but I can. What can I do if they're separate? I can, it starts with a C, ends with combine them. So this is going to be 2 times, I combine this, root 3 over 6. Okay? And then the 3 over 6 will become 1/2. Still in the root. Now, this is 2 times root 1 over root 2. Right? What's root 1? 1. So look, this is over 1. So in the numerator, I have 2, because 2 times 1 is 1. What do I have here?
1, 2, 1.
Okay. So look, here, 2 times 1, 2. Here, 1 times root 2, root 2. I have root 2. So, huh? So this is 2 times 1. 2. Okay? 2. Right, but root 1 is 1. Remember? Yeah. And then this one is 1 times root 2, root 2. Okay, so now I'm going to multiply by root 2, by root 2. Numerator, what do I get? 2 times root 2.
2 over 2.
What do I get here? Huh? What do I get on the bottom? 2. Then what happens? Can anything reduce? This 2 and this 2 reduce. So I get root 2. Drew, can I see you outside for a minute? Anymore, right? These are not that easy anymore. Okay, now they're getting more and more involved. Okay, so remember, so here I have lots of things happening. Fractions, roots, lots of things. First, I'm going to multiply the fractions. Okay? So let's do this first and then you'll do that. Okay, because both of you need to be with me here. Okay? All right. So first we're going to multiply this fraction. Okay? So, look at this one. The 2 times the 4 gives me an 8. And then the root 5 times the root 5 gives me a what? A 5. Okay. Over 3 times root 2. That's all we got. 3 times root 2. So now let's simplify. 40 over 3 root 2. Are we done? No, I need to multiply root 2 over root 2. So let's see. What do I have in the numerator now? 40 times what? So it's just 40 times root 2. That's it. Because one is outside, one is inside, they can't combine. So it's just 40 times root 2. Over 3 times, this will be a 2. So now, look at this one. This and this divide, I get 20, I get 1. So 20 root 2 over 3.
Is it always multiplied by like root 2 over 2 for every problem?
Well, no, it could be anything, but
How do you know what's the root of that?
whatever the denominator is, if it's root 2, you multiply by root 2. If it's root 3, you multiply by root 3. Yeah.
When you're doing e, can you also just multiply by root 6?
When you're doing what?
Like, just using that as an example. Problem e.
Oh,
Multiply both by root 6, I got the same answer.
Right, but then you have root 18 on top, and then you need to cancel, you need to simplify the root 18. If you multiply top and bottom by root 6, then you get 2 root 18 over 6. Is that what you got?
That is what I got.
But then you have to multiply.
And I got it's 6 root 2 over 6, and then it just simplifies to
Right, so you get, 2 root 18 over 6. Yes. And then like this. Right? Yeah. Yes. Lots of different ways to do these. Okay, let's talk about conjugates. Okay? Let's talk about conjugates. Okay, so conjugates are this. If you have a binomial, if you have a plus b and a minus b, they are called conjugates, right? So remember how we said you can never have a root in the denominator, right? Look at these ones. I don't just have root 5. I have 4 plus root 5. So I can't multiply by root 5. I have to multiply by the conjugate. So for this one, if this is 4 plus root 5, I have to multiply by 4 minus root 5 by the conjugate. And then I need to do the same thing on top. Okay, this is heavy stuff we're doing here. Okay, so now here's what we're going to do. Now we're going to simplify this. Okay, in the numerator, we distribute. So I get 2 times 4 is 8 minus 2 times root 5 is 2 root 5. Now, the denominator is a different situation. Okay? What I get in the denominator when I have a plus b, a minus b, before we used to FOIL. But I also showed you guys the shortcut. And we said this is a squared minus b squared. That's what we're going to do. So when we learned that in the last chapter, it was because of this. Okay? So take a look at what we're going to do. You're going to square the first one. What do I get? 16, right? So basically this times this. And then we're going to do this times this, and we're going to get 5. But we're going to put a minus in the middle. Always a minus in the middle. So now I get 8 minus 2 root 5 over 11. Okay, let's do another one. No. Okay, let's do another one. What am I going to multiply this by? This. The conjugate, 2 plus root 3. So, let's see. Here we distribute 6 plus 3 root 3. Here, this one, 4. Ooh, what about this one? 3. What do I put in the middle? Minus. 6 plus root 3. 6 plus 3 root 3 over 1. 6 plus 3 root 3. Okay? It's FOIL, but it's a shortcut to FOIL because we don't want to be foiling with the roots. It gets very, very messy. So, moral of today's lesson. We never leave roots in the denominator. So you have to multiply by the same root. But if it's addition or subtraction, then you have to multiply by the conjugate. So what we have today for homework is another worksheet. Let me give that to you now.